Let's now look at integrals that contain x squared minus a squared. Different than a squared minus x squared, right? So a squared minus x squared means the constant comes first, and x squared minus a squared means the constant comes second. So in the case where we have x squared minus a squared, we are going to do the following substitution. We're going to let x be equal to a secant theta. Let's go ahead and draw the triangle that generates, right? So that means x over a is secant of theta. So if I were to draw that triangle, it's going to be x over a, there's your theta, and then this side right here is going to be x squared minus a squared. Okay? Also, if x is equal to a secant theta, then dx is equal to a secant theta tan theta d theta. Remember, that's got to get plugged in as well. Our domain here, now remember that we had for cosine, it's negative pi, 0 to pi, but because we have 0 at pi over 2 for cosine, we're going to restrict this to just 0 to pi over 2. Okay, and then the identity that we will use likely in this problem is going to be, yet again, the Pythagorean identity, and that is secant squared theta minus 1 is tangent squared theta. Okay, so of course, let's look at an example where we have x squared minus a squared. Okay. Let's do this one. The integral of 1 over x squared, and then times the square root of x squared minus 9. Very similar to the one we had above, but notice that this time it's not 9 minus x squared, it's x squared minus 9. So we are going to let x be equal to 3 secant theta. Dx then is equal to 3 secant theta tan theta d theta. And the triangle that we get is going to be x3, the square root of x squared minus 3 squared, or 9. Okay, so then this integral becomes 1 over 9 secant squared theta. And then the square root of 9 secant squared theta minus 9, and then your dx is going to be 3 secant theta tan theta d theta. Woo! All right, so again, we can factor out that 9 and take its square root. So we will have, I'll just put this on the top, 3 secant theta tangent theta over 9 secant squared theta, and then times 3 square root of secant squared theta minus 1 d theta. Now we're going to use that identity and we're going to replace that with tangent squared. And note that tangent squared of theta is the absolute value of tangent theta, but is equal to tangent theta when tangent is positive, which it is from 0 to pi over 2. All right, so we can replace this with, so those 3's cancel, and I'm left, I can cancel one of those secants with this. So now I'm at tangent theta over 9 secant theta, square root of tangent squared theta, or tangent theta d theta, and my tangent thetas cancel. So I really have 1/9, 1 over secant, but 1 over secant is really just cosine of theta, and that's an easy one, right? 1/9 sine of theta plus c. Now, we're not done yet because we still have it in terms of theta. And at this point, we refer to our triangle and we can pluck off sine, right? It is opposite over hypotenuse. So I should have 1/9 square root of x squared minus 9 over x plus c. That's it.